This first question tested your knowledge of decimals, and if you take 0.02 and raise it to the third power, you will get 8, and because you have two decimal places in 0.02 and you raise it to the third power, you will get the decimal places that require 1, 2, 3, 4, 5, and 6. And so 0.02, 1, 2, 3, 4, 5, 6, and that's where you get your 5 zeros from. Okay, let's take a look at number 2. Number 2 is a cube root. There are 4 things in here, and so x plus y comes out. Cube root of x plus y stays in. So we have a group of 3. Don't forget to put parentheses on your way out. Number 3, the first thing you should have done is some canceling. This isn't really a rationalizing problem because 7 goes into 56 and a goes into a. So what you're left with is the square root of 8b squared. And all you have to do now is simplify that. So b squared, that should be an easy one. The b comes out. And the square root of 8 is 2 square roots of 2. And so that's the final answer. Number 4, similar concept. There was some canceling here. And so this was the square root of 25ab all over 3. A lot of you went and rationalized that. Well, it's not really a rationalizing problem. It didn't have to be. You can do it through rationalization, but it certainly didn't have to be. And so the square root of 25, that's 5, square root of ab all over 3. See how fast that is when you cancel and you don't have to rationalize. Number 5, it could have been a rationalizing problem, but again, the easiest way to do this is to factor. Because the top and the bottom are both square roots, they're the exact same root, that means you can cancel, and the final answer is the square root of x minus y. Okay, number 6, these are both cube roots, but because we're trying to subtract, they need to be identical square roots. So we start with some simplification. This will be 18. This will be x cube root of 2x squared y. And for 128, we'll be able to take out a 2 and a 2, or 4, cube root of 2x squared y. And now these match, and so now I can subtract 18x minus 8, cube root 2x squared y. Okay, next problem was about like terms. We have square roots and cube roots. And so we've got 6 cube root of 3, and we have negative 1 square roots of 3. Number 8 tripped some people up because when they made their box, they thought that 2 cube root of 3 times the cube root of 3 was somehow 2 times 3. Well, that only works with square roots. So 2 times the cube root of 3 is simply 2 times the cube root of 9. Cube root of 9 is not perfect. Minus 5 cube roots of 6 minus 3 cube roots of 4 is the final answer. Number 9. Number 9 did require some rationalizing, but you could have also simplified first. So let's do some simplifying before we do any rationalizing. So you could have divided by 3, and you could have also taken an a out. So the problem could start like this: a cube root of a all over the cube root of 3b squared. So I take an a out, I cancel the 3's. So when I go to rationalize, I do need to rationalize now. I need the cube root of 9b. Cube root of 9b, because I need 2 more 3's and 1 more b. And so that makes the bottom 3b, and it makes the numerator a cube root of 9ab. Number 10 required a conjugate. Some of you still didn't know that you need a conjugate here, top and bottom. 4 squared roots of 3 plus 3 squared roots of 2. And after you make your boxes, you should get 90 plus 40 square roots of 6 all over 30. The numerator has a GCF of 10, which means we could cancel and get 9 plus 4, the square roots of 6, all over 3. Okay, 11. 11 tested a couple of skills. You need to worry about this negative exponent. So the first thing you have to do is bring that to the bottom, and then rewrite that as a radical. This is the square root of y to the 7th. But the square root of y to the 7th either needs to be rationalized and or simplified. And so why don't we simplify it first before we rationalize it. And so the simplified version is going to be y cubed square root of y, because I have 3 pairs in there. And then the rationalizing times the square root of y times the square root of y. So that gives me y to the 4th in the denominator and square root of y in the numerator. And that's our final answer. Negative exponent means I can just flip this over. I can just do the reciprocal and get 8 to the 3/4. And that, of course, is the 4th root of 8 cubed. And many of you stopped right there and said, well, I have a 4th root. I'm looking for 4 of something. I don't have 4 of something. I only have 3 of something. Well, that's not true, because 8 is made up of a bunch of 2's. So what I really have is the 4th root of 2 cubed. 8 is 2 cubed. And so this is the 4th root of 2 to the 9th power. 2 to the 9th power. And I'm looking for groups of 4. And so I can actually take 2 2's out, and that'll be 4 4th root of 2. Number 13 required a distribution of the exponent. Because we're multiplying, I can distribute the exponent. 27 to the negative 2/3, x to the negative 8, and y to the positive 4. Take care of our negative exponents here. These can both come to the bottom. So y to the 4th on top, 27 to the 2/3 on the bottom, x to the positive 8. And the only thing left to do is to simplify this. Cube root of 27 squared. The cube root of 27 is 3. Square it, you get 9. So y to the 4th over 9, x to the 8th. Number 14. This goes back to the first semester where some of you are still not comfortable with the negative exponents. The 3 and the 5 do not have negative exponents. So this is 3 over x squared times negative 5 over x to the 1/4. So what I could do now is I could combine everything. I could say, well, that's negative 15 up top. And this is x to the 9/4 in the denominator. And if I wanted to change that, I could call that the 4th root of x to the 9th. That can be simplified into x squared 4th root of x. And so now I need to rationalize with the 4th root of x cubed, 4th root of x cubed. And so all of this generates a single x, and therefore x to the 3rd power in the denominator, 4th root of x cubed in the numerator. Number 15, easiest way, probably you could rationalize this, but for me the easiest way is to convert to 2/3 and 3/4. Common denominator, 8/12, 9/12. That means I have 1 over x plus y to the 1/12. That needs to be rationalized. And so I can rationalize that with the 12th root of x plus y to the 11th. And so our final answer will be the 12th root of x plus y to the 11th power all over x plus y. Number 16, I have x's and I have y's. Some of you just combined x's and y's, and so x to the 3/6, x to the 4/6. I'll bring this up, I'll bring that down. Y to the 4/5, y to the 1/5. That's going to be equal to y to the 3/5 over x to the 1/6. And that, of course, needs to get rationalized because this is the 5th root of y cubed all over the 6th root of x. Therefore, I need to rationalize with the 6th root of x to the 5th, 6th root x to the 5th, and that'll give us x in the denominator. And some people combine these in the numerator if you wanted to. You didn't have to, but if you wanted to, you could have made this the 30th root of x to the 25th, y to the 18th, or you could have just left this as the numerator there. Cube root of 4 times the square root of 2. Well, at the outset, you can't multiply a cube root and a square root, but if I turn this into 2 squared, or this is what I'll do it the way a lot of people did it, 2 to the 1/2. A lot of people called this 8 to some power. That is not 8 to any power. There's no 8 here. There's only 4s and 2s. And so this has to become 2 to the 2/3 times 2 to the 1/3. I'm sorry, 2 to the 1/2. Or the other way that you could have done it is you could have said, let's go 4 to the 2/6 times 2 to the 3/6. That's the way other people did it. And once you do that, you've got the 6th root. Again, you don't have 8 of anything. You have 4 squared and 2 cubed. Of course, that is going to make a bunch of 2's. It's going to make a bunch of 2's. It's going to make the 6th root of 2 squared squared times 2 cubed. And that makes the 6th root of 2 to the 7th, which is 2 6th root of 2. That's the final answer to number 17. Number 18, 4 to the 1/6 power is the same thing as 2 squared to the 1/6 power, or 2 to the 2/6 power, which is 2 to the 1/3 power, which is the cube root of 2. Finally, number 19. So we need a common denominator here, over 1, and so the common denominator for here is x cubed. I need x squared. So this becomes 1 minus x to the 4th all over x cubed. This becomes 1 minus x squared all over x squared. And then we can flip and multiply. So this is 1 minus x to the 4th over x cubed times x squared, 1 minus x squared. Cancel. That's 1. And then I can also factor. This becomes 1 minus x squared, 1 plus x squared over x times 1 over 1 minus x. Should be a 1 minus x squared. Ran out of room here. And so the canceling, boom, boom, final answer, 1 plus x squared all over x. And finally, solving this, most people were pretty successful. Let's see, so we need an x minus 1 here because this factors into x minus 1, x plus 1, and so this becomes 10 plus 2x squared minus 5x plus 3, and on the other side, if we want to give this an x plus 1 to get a common denominator, we could do that as well. That'll become 2x squared plus 5x plus 3, and then we could start to cancel. Those go, those go. This becomes 5x equals 10 minus 5x, which becomes 10x equals 10, x equals 1. No solution because x cannot equal 1.